Hey guys, my name is ezTech, and in this video I'm going to show you the ezspline command from ezEdits and tell you everything there is to know about it. Let's get right into it. The ezspline command requires you to have a convex selection. I'm just going to use the easy wand or super wand from ezEdits to quickly draw one out right now. Something like this should work. Now the most basic ezspline command out there is ezspline basic. Its syntax requires the pattern next. We're going to use clay for this one, and then followed by the radius. I'm going to use 15. And there we go. Just a reminder, the super wand from ezEdits can be quite useful when working with convex selections, allowing you to add and remove positions relatively quickly, and most notably, allowing you to move around each position at will. Now, you might notice that this result looks quite similar to existing commands, more specifically WorldEdit's curve command, which also takes in a pattern and then a radius, and Archeon's spike tool, which also takes in a pattern and then the diameter. So we type in 30 instead. Takes a few seconds longer, but there we go. Now, if you pay close attention and compare the results, you might notice that ezEdits spline creates a much smoother result than both the curve tool and the spike tool. To illustrate, keep an eye out for erroneous blocks like these, and notice how curve and spike produce a less clean contour compared to ezspline. Let's also compare what happens if we use two radii with ezspline. You do that by comma separating the radius argument, so we're going to type in 15,1, and the equivalent for the spike tool would be 30 and 2. And there we go, now we've got two spikes. Comparing the results yet again, we can see that ezspline creates a much smoother and more faithful result than Archeon does. However, a more accurate result is not the only thing that ezspline has to offer compared to the currently existing tools. The main feature, of course, is being able to have any spline shape you want. For example, we can swap out the basic one with this rope one, but in general, we can embed literally anything we want into the spline shape, including expressions, noise-based shapes, schematics, or even clipboards. This expression, for example, can create an arched bridge. This expression can create a DNA strand. And using the ezspline structure command, we can easily embed clipboards and schematics. For example, if we have a schematic named roads, we would type ezspline structure schematic, file name roads, and closing the bracket and pressing enter gives us this result. In addition to being able to embed any spline shape that you can come up with yourself, there's also a large set of predefined spline shapes that you can use, such as polygons, stars, flowers, fishnet, and so on. We can also customize the radii at any point, such as with the spike example before. If we type in, for example, 30 and 10, ezspline will even scale up and down the schematic such that it matches the desired radius. On top of that, ezEdits also offers quite a lot of modifiers to modify how the shape is being rendered. For example, if you type in -t and then 45, then you're using the twist parameter to twist the spline as it goes through the path. Another thing you can do is render the spline using shaping blocks like stairs and slabs. For example, if I type this, I can tell ezspline to try and use slabs instead of the default input blocks wherever possible. And just to point it out, all of these modifiers and settings are working completely independently of each other. You can mix and match them as you like. Now, before we move on, I just wanted to point out something else. If I generate the cubes spline shape using ezspline 3D cubes, I'm gonna use clay and 8 this time, you'll notice that these cubes are actually not quite perfect cubes. In fact, they are bent and deformed in such a way that all parts of the shape always perfectly follow the initial path on an offset. You can, for example, see that on the inside of these curves, the cube gets compressed. Meanwhile, on the outside of the curve, the cube gets stretched out. If there is something that you do not want to happen, you're probably looking for a very similar command, ezarray. ezarray simply pastes shapes, clipboards, and schematics at multiple positions along the path, as opposed to embedding the shapes in and around the path itself. Another interesting comparison is when we generate the road example from before, once using ezarray and once using ezspline. Hopefully that makes the difference between those two arguably similar tools clearer. Now, that concludes this small little overview of ezspline. If you want to learn more about the tool and how to use it, then keep watching, because for the rest of this video we're going to go through all of the parameters and options. And we're actually going to do that by closely following the wiki, because it has all of the information within this video, if not more, in a convenient format. And so, if you type in /ezEdits wiki, You can get the link to our wiki right from inside the game. Let's scroll down to the Spline page right here. As you can see, the documentation for ezspline has been separated into 4 pages. The first page covers all of the modifiers and arguments that are available to all ezspline subcommands. The second page covers 2-dimensional predefined shapes. The third page covers 3-dimensional predefined shapes, and the fourth page covers the most difficult but also the most powerful commands: noise, expression, and structure. Technically speaking, you could create any shape that you want using expression spline and the structure spline, but of course coming up with the expressions to create all of the desired shapes might not be as intuitive for most people, so we do provide all of those 2D and 3D spline shapes for your convenience. So let's start off with the common parameters page. This page covers all of the arguments and flags that are available to all ezspline subcommands, starting off with the radius argument. We're going to use ezspline rope as our example spline shape, and following the syntax of the command, we type in ezspline rope and clay for the pattern, and then towards the radius. So before we have just typed in 15, so let's do it again just to confirm. And there we go. This spline is now roughly 30 blocks in diameter, but of course we can not only provide the one value, we can provide as many radii entries as we want. So for example, if we type in 15 and 1, we get the spike shape as we've seen before. We could also add in a third entry, so 15, 1, and 15 produces this kind of result. We can also add in more entries, so adding another 1 and another 15 gives us this. In fact, you can add as many comma-separated radii entries as you want. Another feature of the radii argument is being able to specify the relative positions of each radius entry. You can think of them as keyframe positions, so to speak. So if we use this example where we have 1, 15, and 1, by default, radius 15 will be reached at the exact center between the start and end of the path, because it is the middle entry. But you can also modify the position of where the radius 15 should be reached by typing in a number between 0 and 1 and a colon before the radius entry, something like this. And so we can, for example, say that radius 15 should be reached at 30% of the spline length instead of 50, which gives us this result. We can also move it further along the spline, so we can type in 0.7, for example. Now the keyframe position, so to speak, of our 15 radius entry has shifted. Keep in mind, though, that all of these relative positions along the path are completely independent of our convex selection. Where exactly you put each position has thus no direct influence on the radii entries. Moving on to the Krushenick-Bartel parameters, you are able to define the tension, bias, and continuity of the path that you are laying out using the input nodes. We suggest looking at this graph to quickly assess what each of the parameters does. We have continuity in the first row, tension in the second, and bias in the last row. Careful though, the diagram actually shows them in order CTB, even though the command expects TBC. So let's run through a few examples. For example, if we set the tension to 1 and both other values to 0, which we do by typing in 1, 0, 0, colon separated, then we get straight line paths between each of the convex selection nodes that you laid out. Another interesting result is also setting the tension to -1. We can see what happens if we do that. Here we are. But in general, to use this parameter, you just look at this table, look at this diagram, and see what kind of path you want between your nodes and just copy the values that result in the path that you want. Next up, we've got the quality parameter. ezspline allows you to render the spline in 4 different quality presets: fast, balanced, high, and exact. Fast renders the spline in the least amount of time by compensating for quality and accuracy. Balanced is the middle ground between runtime and accuracy, while high and exact produce the most accurate results, but also take quite a lot longer than the others. Just to show off the difference, here are 2 identical splines. One has been rendered in fast mode, the other has been rendered in balanced mode, and the third one has been rendered in high mode. You can see that in fast mode you can get quite a few erroneous and/or missing blocks. Meanwhile, in balanced mode they are way more uncommon, and in high mode they are almost practically gone. It also might happen that using lower quality presets, the spline might glitch. So if you find yourself getting unexpected results, then trying a higher quality preset might be the solution. However, when I'm talking about errors like these, I'm not talking about the case where the spline shape becomes so thin that it stops being able to render itself. For example, if we have this really thin tube and we shrink it down using multiple radii, like 15 to 1, then we do get quite a few missing blocks, but that's not because the quality is not high enough. It's simply because the spline shape is simply not thick enough to be rendered at that resolution using full blocks, meaning those two are different problems. For cases like these, you'd need to increase the thickness of the spline shape that you are working with to be able to render it at those smaller radii. Moving on to the stretch parameter, it's a simple value that allows you to stretch and or compress the spline shape in the direction of the spline path. For example, if we go ezspline, 3D, chain link, clay 15, by default it looks like this, but now we can add the -s flag. The default value is 1. If we type in any number larger than 1, then the spline will get stretched out, so let's type 2. There we go. Now if we use any value between 0 and 1, then the spline shape will get compressed by that factor. So let's type in 0.5. And that's how it looks like. The wiki also provides this quite intuitive GIF. Moving on, we also have two flags that control rotation around the spline path, what we call rolling or twisting. The first one being the roll parameter, -r. You can either set a constant angle, or you can type in two angles, so a start roll and an end roll, effectively twisting the spline along the path. Just to quickly demonstrate, let's use a squared spline. So we type in ezspline, 2D, square, clay 15, and by default it starts off, vertically aligned to the y-axis. However, if we now type in -r45, then the spline gets rotated around the spline path by 45 degrees. You can also type in another angle, so for example 30, and we get this. Or like I've mentioned before, we can also provide two values, a start and an end roll. So let's type in 0 and 90. In this case, the spline will roll around throughout the length of the spline, starting with a roll of 0 and then ending with a roll of 90. You can see that happening. This corner goes from this end up to that end, which is a 90-degree rotation. We could also specify 0 and 360. Then we get this kind of result. Now it does a full 360-degree rotation throughout the length of the spline. However, you might notice that a start and an end roll actually makes a twist, or how strongly the twist appears in the end, highly dependent on the spline length that you have. So if we shorten our spline length to, let's say, this much, then the twist that we get in the end from a 360-degree rotation is way stronger, or appears way stronger, than it did with a way longer spline. And so for that reason, we also have the twist parameter. The twist parameter allows you to specify a rotation that is applied per unit of length, so it is independent of the final spline length. The longer it is, the more rotations it can do. So yeah, sometimes you want the twist parameter, sometimes you want to define a start and an end roll angle. You have the option to do either. Moving on, we have the three different normal modes. I'm going to load in the following path and create a rectangle spline, which gives us this wide but thin band. Now, if you pay close attention, if we walk along the path, it starts off horizontal, meaning the left and the right sides are level. However, in order for the curve to appear as consistent and as smooth as possible, ezspline rolls the spline shape, such that by the end of this curve, the spline shape has rolled enough that you can notice it is not level anymore. You can see that the left side and the right side are at different heights. In consistent mode, the spline shape is able to pitch, yaw, and roll, allowing for the most smooth and consistent look. However, you can also restrict it further. If we use horizontal mode instead, then we get this. As you can see, the spline is not rolling anymore. It keeps itself horizontal and level at all times. But we can go one step further. If I add in another spline, which is supposed to represent pillars, for example, by doing a cube spline with a larger gap, and let's say we compress it also with a factor of 0.5. And of course, by default in consistent mode, they still roll, so I turn on horizontal mode instead. But now you'll notice that the pillars, or what I want the pillars to be, are still perpendicular to the path, which is not really what we want. We want the pillars to be vertical. And so for these kinds of cases, the upright normal mode is what we want. Now our pillars have become vertical or upright. You can also interpret it as the spline shape not being able to pitch anymore. It can only rotate horizontally, no pitch nor roll. So there you go. Consistent allows all three rotations, horizontal eliminates the roll that we get out of curves, and upright eliminates pitching altogether, resulting in a totally vertical appearance. Another example that I want to show before we move on is a convex selection which has steep and or vertical sections to it. Running our square spline along this path again, we can see that in consistent mode, it still does look like you'd expect it to. However, if we now move on to horizontal, you'll see that in order to stay horizontal, it does quite an aggressive twist at this particular steep section. If we switch to upright now, it does not look much better. So yeah, just wanted to point out that these two modes inherently struggle with steep and or vertical sections. Moving on, we have the end style parameter. This is a simple parameter which determines how the spline ends look. If you remember the first examples at the beginning of the tutorial where we compared spike curve and ezspline, you've probably noticed that ezspline by default has quite an abrupt end. However, we can change that, of course. There are 5 modes: flat, soft, spike, round, and cube. And I'm guessing you can see what each of them does just by looking at the pictures. Now let's talk about one of the most powerful features of ezspline, the ability to generate and place shaping blocks like slabs, stairs, and even snow levels. We've seen an example of this earlier with the slabbed road. The way this works is by adding the -w arg flag to your command. When you use the -w flag, you need to provide a profile. Think of profiles as presets that use a specific set of shaping blocks. For example, the slabs profile only uses slabs. Another profile might use both slabs and stairs, while a third could use them in different orientations. Each profile is hard-coded to achieve a certain look. By default, when ezEdits tries to place a shaping block, it will use the pattern or palette that you've specified. However, suppose the variant doesn't exist in the given material, such as there being no clay slab. In that case, it tries to find the material that most closely matches the given pattern, palette, or the existing block in the schematic by color. If you don't like these automatic choices, you can also overwrite the material for the shaping blocks. For example, if you wanted the slabs to be made of acacia, you would type -w slabs and then in brackets slab : acacia. And that's how you can leverage the SmoothBlocks parameter to add another level of detail to your creations. Alright, here we are. And just to reiterate, all of these parameters from these last couple of minutes are available for all ezspline subcommands, meaning you can roll, stretch, and twist all of the spline shapes that we have. Everything works completely independently of each other. We may also add more parameters in the future, so the tutorial may become outdated. In any case, just reference the wiki. And with that, we can flip over to the next page. Now we're going to take a look at all of the default spline shapes that ezEdits comes with. The idea and syntax is pretty simple. You type in ezspline 2D and then any of these shapes, followed by the pattern and then the radii. Here we go, a circular spline shape, which is, by the way, what is called when you type in ezspline basic. It just calls the 2D circle shape. Moving on, we have squares, we have diamonds, we have rounded squares. In brackets, you always see the abbreviations. So for example, you could type in ezsp 2D and then di for diamond, clay 15. And it all works. If we scroll down further, we reach the first shape that has a parameter to it, the supercircle. The supercircle has an internal parameter called the exponent. If we type in ezsp 2D supercircle and then opening the bracket, you can see that it auto-completes the available parameter, in this case exponent. So at this point you type in the number that you want and then close the bracket off again, and then continue as normal, clay 15. So as you can see, all of these parameters that influence the shape itself always come in brackets after the shape. In this case, for the supercircle, the exponent value lets you choose between a plethora of shapes. We also have an interactive preview. It's this Desmos link. You can preview what the parameter does using this slider. As you can see, with an exponent value of something smaller than 1, we get star shapes. If the exponent is 1, we get this diamond shape. At the value of 2, we get a perfect circle, and with ever increasing exponent values, the shape approaches a square. But here you go. If you like the shape, you can just copy the value right from Desmos to in-game. Let's say I want this shape, and I see, okay, my exponent is 3, so I type in 3 in-game, and here we go. We get the shape that we have chosen in the Desmos preview. The same idea applies for all of the remaining spline shapes. For example, the circle. If we click on the Desmos link, you can see that it's just a circle of circles. Thus, it's the circle's circle. You can change whether you want the inside to be filled or not and how many circles the circle's circle should be made out of. Let's say I like these values. Then I just copy them. So we type in ezspline 2D. I can type CC because that's the abbreviation, as you can see here in the wiki. And then the amount, 6, filled, true. And there you go. For 3D spline shapes, the syntax is identical. You type on ezspline 3D, then the shape and the pattern yet again, and finally the radii. Any parameters that influence the shape itself are put in brackets after the shape, just like the 2D spline shapes. And just like before, all shapes have a Desmos preview link, so you can yet again play around with the parameters, play around with the shape, choose the values that you like, and then once you're done, you can just copy the values into chat and generate the shape in-game. I'm gonna leave out talking about each individual parameter of each individual shape, just because all of the Desmos preview links do provide an interactive preview, which are way more helpful, giving you an understanding just by playing around with them compared to me trying to explain them. Which means now we're going to talk about the advanced spline shapes. These subcommands are very powerful, but also more complex, and offer effectively limitless customizability. First up is the noise spline. You use it by typing ezspline noise followed by the palette and radii. You can add a noise argument, a depth argument, and common parameters. Note, however, beforehand all of the other shapes were accepting a pattern. Here you may use a palette. That's a list of blocks compared to, most often one singular block. Meaning we can type something like ezspline noise and then hashtag grayscale for the default grayscale palette, and then 15. Next up, we can put in a noise preset. The noise parameter lets you specify the noise to be embedded along the spline path. The default value for the noise parameter is a Perla noise with a frequency of 2 and also stretched out along the z-axis by 0.5. I would suggest using a frequency of 2 as a base value for this specific command. Then there's the depth parameter, which controls how deep the noise cuts into the spline. A depth of 0 will approach the original cylinder shape. 0.5 means the noise can carve up to half the radius deep into the cylinder, and 0.1 means the full radius. That's actually it for the noise spline. However, I still felt like I could show off the capability of the noise spline with a couple of demos that I quickly threw together right now. I added them to the wiki as well for your reference. You can see what kind of noise settings I was using, for example. But yeah, you can scroll through here, check it out if you like. This last one is interesting because I made it cut off flat and used the upright normal mode to generate walkable, floating islands like these. But yeah, like I said earlier, since it can get quite complex if you really wanted to, ezspline noise is a very powerful command. Next is the expression spline. This generates a spline shaped by a WorldEdit expression. The syntax is ezspline expression followed by the palette, radii, and the common parameters. But in any case, the expression itself is the very last part within the command. So one of the simplest examples might be something like ezspline expression, and let's say clay 15, and then let's do a simple cylinder or a circle, which would be x squared plus y squared is smaller than 1. And there we go. If you've ever used LessGenerate from WorldEdit, then this is pretty much the exact same thing, except that the domain space is warped and bent along the spline path. In this case, x and y go perpendicular to the spline path, and the z-axis runs along the path. But seeing as this is in fact quite an advanced command, I'm not gonna be talking about it much longer. All of the details for everyone who's interested can be found on the wiki. In any case, you're probably better off reading the details if you're interested in working with this command. Finally though, we have the structure spline. This one embeds a structure along the path. The syntax is ezspline structure followed by the structure to embed, radii, and the common parameters, and there is also a z flag. The structure will be placed with its z direction facing along the path, that's the north-south direction when you copy it. Multiple instances are repeated, as many as they can fit into the given path, unless you use the -z flag, which stretches out one instance of the structure across the entire path, which can create some really deformed results like these. The structure spline is also the only spline subcommand for which the radii argument is optional. If you leave out the radii argument, the structure will be generated at its original size. But if you want to scale up or down the structure, you may choose any radius you want. Note, however, that the radius does not inherently represent a dimension of the structure, but rather the radius required to fit the structure. So for example, this road schematic, neither the width nor the height is like 18 blocks tall, but in order to fit the entire road schematic at its original size into a spline, ezspline has automatically calculated that it needs a 18.5 radius. You can also see that if we use a different origin, then the required radius also changes because you just need more real estate to fit the shape if it's further away. As you've seen just now, the alignment of the structure, like perpendicular to the path, depends on the structure's origin. The structure's origin is always set on the path. If the structure's origin is, for example, set to center, then the structure's XY center point will be placed directly on the path. If the origin is set to inherent, then the structure's inherent origin will be placed on the path. That would be wherever you type // copy. For example, if you were standing on the upper left corner of your structure and then typed copy there, using inherent origin will place the structure below and to the right of the spline path. Here's another example of the structure spline. In this case, we have a structure which is a heart shape with a purple gradient inside it. But in general, you can use any of the available structures, this link right here. And that was the structure spline. And that actually concludes this tutorial in its entirety. If anything didn't stick on the first watch, make sure to use the chapter timestamps. They might be quite helpful. If you have any further questions, feel free to ask them in our Discord. And anyhow, I hope you found the video helpful, and I'll see you in the next one. Goodbye!